can you solve this equation in a beautiful way? Like, what is elegance in mathematics, and what would it look like solving this question? Because there's multiple ways that we can do this. One of the ways is that we can literally just expand everything and we get a quartic equation. And that quartic equation, although it's tricky to factorize, it's not impossible. For algebra, you would be able to spot that factorization. But is it elegant? What I tend to advise my students is to, whenever we can, don't expand, but to keep factorizing so that everything kind of stays neatly in its brackets. So that's exactly what we're going to do here. We can notice that this bracket, 1 minus x squared, well, that's a difference of two squares, so we can factorize that. So we can get 1 plus x squared times 1 minus x squared, and this side stays the same. Now, there's two ways that we can go from here. We can either notice that we've got lots of 1 plus x's and a couple of 1 minus x's as well. So we could substitute an a for the 1 plus x and a b for the 1 minus x. Personally, I recommend against doing that. I don't know why, I just, personal preference, don't think it helps. So what we can do though, is either way, we're trying to factorize this. So we're going to move this over to the other side. So we've got 1 plus x to the 4 minus our middle term, 1 plus x squared times 1 minus x squared, minus the 2 times 1 minus x to the power of 4. Because this term is like the 1 plus x squared, and that's where this middle term is going to come from as well. So we know in our brackets, we're going to have our 1 plus x squared as the first term in both brackets. We're going to have our 1 minus x squared as the second term in each bracket, but we need two of these. So we're going to subtract 2. And then for our middle term to add to minus 1, well, we've got to add here. So if we just double check that this works, 1 plus x squared times 1 plus x squared is 1 plus x to the power of 4. 1 plus x squared times minus 2, 1 minus x squared is minus 2, 1 plus x squared times 1 minus x squared. But then we're adding one of those back to get our middle term, and then these two multiply to our last term here. So we've successfully factorized this, which is great. And now we can actually simplify the parts inside each of these brackets. So 1 plus x squared plus 1 minus x squared. Well, a lot of terms are going to cancel here, and we're just going to be left with 1 add 1 and x squared add x squared. So this first bracket becomes 2 plus 2x squared. And the second bracket, well, we get 1 plus 2x plus x squared minus 2 plus 4x plus x squared. Let's write that down. We get 1 plus 2x plus x squared minus 2 plus 4x minus 2x squared. And we'll do a little bit of simplification here. So we get 2, 1 plus x squared, and we've got minus 1, let's just start it, minus x squared plus 6x minus 1 equals 0. Well, we've got three things here multiplying to 0. 2 can't equal 0. 1 plus x squared, well, x squared is always positive because x is a real number, and 1 is always positive. So this part is always positive, so thus cannot equal 0. So the only thing that we're left with here is that this last part could equal 0, and that's going to give our solutions for x. And we can swap the negatives around by setting this part equal to 0. So x squared minus 6x plus 1 equals 0. We're not going to be able to factorize this, so we're going to have to complete the square. So we get x minus 3 squared minus 9 plus 1 equals 0. So x minus 3 squared equals 8. So x would equal 3 plus or minus 2 root 2. And that is our final answer. And I really want to hear your opinion in the comments. Is this an elegant mathematical method? What makes it elegant? And do you think there's a better way to solve this? Looking forward to seeing your replies in the comments.